tricalcium silicate is. Now, anybody know what tricalcium silicate is? It is the primary hydraulic compound in Portland cement. So you can actually have all the best intentions of the world and produce a traditional material, but you can basically still form a natural Portland cement, and then you have some of the problems in chemistry that you have with cement in historic buildings. So you do have to be careful with the burning temperatures of hydraulic materials. So, in summary, on the mortar side of things, we're doing okay on that, right? How do we make historic mortars? We've talked about the clay mortars. Now that you've seen quicklime in action, what happens with quicklime slates, you realize why that small amount of quicklime would have been added to the mortar, to the clay mortar, to help dry that mix out, start to take some of that moisture out of that clay mortar. We talked about the hot lime mortars, very common material. Lime putty mortars, again, were used traditionally. Thomas Jefferson's Poplar Forest, we were on site there. My father's a bricklayer, still lays brick 4 days a week. He was the main mason at Poplar Forest for about 15 years. That was a putty mortar there. There was certainly there. But you often see putty mortars combined with protective treatment, which we're going to talk about in just a second. You also have your hydrates or your NHL mortars, your natural hydraulic limes. Today, because of the problems of shipping quicklime and whatnot, most of your hydraulic lines are produced in a hydrate form. They come as a powder. You add water to it. That triggers that hydraulic set to take place and allows that carbonation to continue. And then you have your natural cement mortars, which are often a natural cement that is used as a gauging to either a hot lime mortar or a lime putty mortar. Now, in certain situations, let's say you're building a bridge or you're doing a canal, you want to make sure that mortar is as strong as it is and as waterproof as possible. So in those cases, you might see just a blend of natural cement and sand. That certainly wasn't uncommon, but natural cement being used as a gauging material was certainly very common as well. So let's talk about just physically what's bad about Portland cement in a historic building. This little diagram here, and these slides will be available online, I think, in the next day or two through the conference. But basically, 1830s, we've built a building. We've got 2 brick bedded in a lime mortar. Can anyone tell me what type of lime mortar that is? Is it oyster shell lime mortar? Thank you. Okay, a little chuckle from the audience. Y'all are a tough crowd. Are y'all just ready for this thing to be over? Ready for Friday to kick off? I am. It's been a very long week. Now let's look at this. Built in 1830 or so. Nice kind of overhand struck joint. You have that little joint profile there where the mortar is struck off in that fashion. And after 100 years, 125 years, you have a little bit of deterioration. You have a little bit of decay. So you want to point it up. Now, 1950s, everybody's got a little bit of money, coming out of World War II. You use what's available. And what's available is Portland cement. You go ahead and throw it up there. You pay no attention to the original joint profile. You just run a slicker down it, and now you've got this nice concave joint, which has no historic precedent whatsoever. And okay, now the work looks very pretty. 20 years later, that cement mortar, which is hard, which is impermeable, which does not allow the mortar to act as it's supposed to. In historic buildings, the mortar joint did a couple of things. One, it was a natural wick. As moisture went into the wall, it would go through the soft lime mortar and evaporate out. So it was a natural wick for the masonry. It was also the expansion joint or the control joint of the wall. Historic buildings were made up of millions of control joints. Each one of these soft lime mortar joints, in essence, was an expansion joint. You've also killed that process. So you've put this hard, impermeable mortar there, and now moisture is going to be trapped. Now, lime, even lime that's 100 and 200 years old, is still somewhat soluble. So what happens is that lime starts to leach out, starts to escape from the building, and leaves just sand in that void. This lime leaching, in theory, is actually a very good thing. In historic buildings, this is why control joints weren't needed. Over time, as the building expanded and contracted and somewhat settled and whatnot, little small fissures, little small cracks would open up. Now, moisture would enter into those cracks, grab little particles of lime and pull them to the surface where they would then carbonate and basically heal themselves. Lime mortars are self-healing mortars. You don't really have to deal with movement cracks and whatnot. Now, if you have a seismic shift and the whole building drops 6 feet, good chance that the mortar's going to crack. More than likely the whole building's going to fall apart. But for the most part, any small movement, that lime mortar is able to accommodate. So here in the 1990s, we've seen that lime leach out. Now you've just got sand back there. And through the normal expansion and contraction, and as the building starts to move, a lot of times you see the masonry just reject the Portland cement. It just literally falls off the wall. And then you've got all this kind of cruddy sand in the background. Now this is an example of lime leach here. So you can see where the Portland cement has separated from the stone, caused a little void, and that's been an avenue for moisture to rush in, grab that lime, bring it to the surface where it's leaching out. And then when you remove that Portland cement mortar, you think, wow, this lime mortar has done great over the years. It's just crumbly and it's a mess, but that's because the lime has been leaching out of it for the past 20 years. You would certainly not want to put more Portland cement because that's just going to continue this process on and on. And I will admit this picture was taken in a very harsh condition. This is in Newport, Rhode Island, but it's a good example of what can happen to historic brickwork. The brick originally looked like, but as the mortar joints, the natural wicks of the building were closed up with these hard Portland cements, the moisture just sat in the masonry units themselves. And when freezing came along, then you had freeze-thaw issues and whole faces of the brick start peeling away. You also see the same sort of thing happening on buildings that have been painted with latex paint. Latex paint being a rubber-type membrane will do the exact same thing. It cuts the breathability of the masonry off, and then that moisture stays in those masonry units and then freezes, and then you see the brick just cowering and deteriorating away. Fort Washington National Park in Fort Washington, Maryland, a prime example of what can happen just by using Portland cement. In the 1960s, there was a certain amount of wear and tear to the Fort Washington. I think the structure was built between 1815 and 1830, if memory serves. By the 1960s, there was some money in the Park Service. They said, we're going to fix this up. And they actually relayed a lot of this work. And you can see that they didn't even bother bonding it. That was part of the problem, too. But they relayed this whole section of wall with Portland cement. You can see it right there in that corner. Over time, excuse me, I'm starting to crack a little bit. Over time, you would that lime is leaching out of the walls. The sand is sitting there and it's settling. The sand's there. There's nothing holding it together, so it's just falling through the mortar joints. And you start to see this jacking action happen. And just over time, this entire white of masonry fell on the ground. Unfortunately, you can't see, but there's a huge pile of bricks just below the bottom of that picture. The whole work was then relayed with a lime mortar a few years ago, and everything's doing just fine. So, how should you finish your mortar? Some people, particularly in Europe, are big advocates of the restoration joint, where you take and you point up the wall, and then you beat it with a brush, and you make it look old and rustic and whatnot, and historic, and everything looks great. I don't agree with that at all. When you're finishing lime mortar, there's a certain skim that comes to the surface, a certain latent that comes to the surface of that mortar joint. That's a protective level as well. That is going to help close the pore structure somewhat up and help prevent freeze-thaw issues later down the road. It's also important to take a look at your historic building and try to find out what they were doing originally, what the original joint treatment or joint detail of the masonry was in the first place. It's like this. You've got a continual decay cycle. It's a maintenance issue. And if you don't replicate what was originally there, there's a good possibility in 10, 20, 50 years, nothing original will be there anymore, and then that's lost for all time. So I think it's very important to take a look at the